Okay folks, today's video we are looking at absolute value equations and more specifically solving absolute value equations. You've been solving equations for years now. All that's happening now, especially throughout Math 20 Pre-Calculus, is we're just looking at different types of equations. So absolute value equations is what we're going to be looking at today. But if we look back, okay, in the last 2 units, we were also solving equations, right? Okay, for example, the square root of 2x plus 1 equals 7. Okay, we know how to solve that equation now. We know that we just square each side. We get 2x plus 1 equals 49. We subtract 1 from each side. Divide each side by 2. Sorry, that should be a 48. And we would get x equals 24. Okay, we know how to solve that. We also know how to solve rational equations now. So if I give you 2 over x plus, let's say, 5 over x plus 1. Sorry, that's a mess there. 5 over x plus 1 equals 7. Then we know how to solve that. We know that we just solve or multiply everything by the lowest common denominator. Okay, so we would just multiply everything by x times x plus 1. That would get us all the x's on the numerator, which is a strategy we need to solve rational equations. So with an absolute value equation, we're not going to be squaring each side. We might have fractions. Okay, we might have to use this strategy of multiplying the lowest common denominator. But the purpose of me showing you this is, when we get into each different type of equation, there's going to be a little trick to solving them. With a radical equation, the trick is isolate the square root and then square each side, or cube root, whatever. In rational equations, we have to multiply everything by the lowest common denominator. That gets all the x's off the bottom. Okay, then we can isolate the x's. Absolute value equations is going to be no different. There's going to be a little trick that's going to help us solve absolute value equations. So let's take a look. So really the trick to solving an absolute value equation is that when solving an absolute value equation, we have to remember the definition of an absolute value. Okay? And if you remember the definition of an absolute value, we had a piecewise function, right? Y equals the absolute value of whatever it might be. Let's just call it x minus 1 to make it easy. And sorry, that was a mess. X minus 1. Well, remember that function can also be negative over a certain domain. Okay, this will be positive if x is greater than or equal to 1. And it'll be negative if x is less than 1. So remember, when we pull what's inside out of the absolute value, it can be positive or it can be negative. So when solving, we have to consider that there are two possible ways to solve. One possible way to solve is we take the expression inside and assume that it's positive or 0, and we bring it out exactly the way it looks. The other case to consider is that the absolute value inside is negative, okay, which comes back to our piecewise function. Okay, remember there's two cases for each absolute value. There's either we can pull it out positive, our answer will be positive, or it'll be negative, and we have to multiply by that negative to make it positive. So there's two cases we have to consider. We have to consider the fact that it's positive or 0, and then in that case, we just bring it out. But if the expression inside the absolute value is negative, then we would have to times it by a negative. So when we solve absolute value equations, we have to pull whatever's inside the absolute value signs out. And we have to pull it out twice and solve. We have to pull it once as a positive and once as a negative. So really, we just have to solve twice. That's the trick to an absolute value equation, is we have to solve twice. Once as if the inside of the absolute was positive, and one as if it was negative. So let's just take a look at some examples, and I think it'll come straightforward. Alright, so example 1 that we're going to look at here. Example 1 wants us to solve this absolute value equation graphically and algebraically. So we'll look at it graphically first, then we're going to look at it algebraically second. Okay, so to solve this graphically, what we do is we actually look at this equation here and we break it up into two separate functions that we're going to graph. Okay, first off we graph y equals the absolute value of 6 minus x, and then we graph y equals 2. Okay, so we graph each of those, and then now that we have two separate equations that are really representing this one equation, we know how to solve systems of equations. Solving a system of equation is just looking for where do the two graphs intersect. Okay, so if we graph this and we graph this, we just got to look at our graph and say, okay, where do these two graphs intersect? Now, we can graph these both on our graphing calculator. I can't really show you right now over this video, so remind me tomorrow in class and I will show you how to plug an absolute value into your graphing calculator, and then obviously you know how to plug this in, and then we know from our solving equations unit how to find the intersection points of two graphs. Okay, but for right now we'll just do it old school by hand. So let's start by finding the x and y intercepts for our absolute value function. Okay, so if I sub in a 0 for y, I then get 6 minus x. Then I can add an x to each side, and I end up with x equals 6. And if I sub in a 0 for x, I get y equals 6 as well. Okay, so I have my y-intercept at 6, so let's go up 1, 2, 3, 4, 5, 6 right there. And to the right, 1, 2, 3, 4, 5, 6 right there. Okay, and remember, I know this side of the graph now. Okay, it's going to look like that. Okay, but I still need to know another point over here. Okay, so whatever you want to sub in, just an x value from over here and solve for y. So let's sub in 8. Okay, 8's right here. Okay, so we go 6 subtract 8, which is negative 2, but remember we take the absolute value of that, so we get 2. So let's put that on 8, and 2 is right there, so our graph finishes like that. Okay, so the last step we have here is to draw our y equals 2 part of the graph. Okay, so let's draw y equals 2, and that goes right there. Okay, and this goes to show why you have to draw your graph so accurately, because the answer are here, and it should be here, and we would think 1, 2, 3, 4, 5. So 5 and 2 and 8 and 2 should be our answers. 8 and 2 is right, but 5 and 2 is not. It should be 4 and 2. Okay, and if you look at my line, it's really not drawn even close to accurately. I should be here and through there. Okay, so that should be my line. If I try to draw this one a little more accurately there, now you can see the true points on which we should be intersecting. So there and there are my 2 points. So the solution, the 2 possible x values, okay, are 4. Sorry, that was a mess again there. Are 4 and 8. Okay, because those are the 2 x values on which our graph, 2 graphs intersected. Okay, so that's how we can solve this algebraically. Now let's look at how we can solve, that's how we can solve this graphically. Now let's look at how we can solve this algebraically. Okay, so solving this algebraically, this is pretty straightforward. Like I said, you just have to remember that there's 2 cases that we have to solve for. Okay, case 1 is that the inside of the absolute value is positive. Okay, so that's the first case. The second case is that whatever is inside is going to be negative. And when whatever inside is negative, remember we have to multiply by a negative to make it positive, because this always has to be positive. So now we just have to solve each one of these separately. Okay, so let's just, whatever way you want to go about it, subtract 6 from each side. Okay, we get negative x equals negative 4. Divide each side by negative 1. X equals 4. And the second case, okay, remember you have to distribute this negative in. Okay, so I get negative 6 plus x equals 2. Add 6 to each side. And x equals 8. Okay, so our 2 possible answers, just like in the graphical answer, are x equals 4 and x equals 8. Okay, so 2 different ways to solve, and we got the same answer. So now that we have a good idea of how to go about solving these, let's just work our way through a bunch of examples here. Alright, so for this question, we're given a little word problem. We actually have to come up with the absolute value equation